In this presentation, we're going to learn how to graph trig functions without having to kind of graph point by point. And hopefully, after this presentation, you can also look at a trig function and be able to figure out the actual analytic definition of the function as well. So let's start. Let's say f of x. Let me make sure I'm using all the right tools. So let's say that f of x is equal to, let's say it equals 2 sine of, let's say, 1/2 x. So when we look at this, a couple interesting things here. How is this different than just a regular sine function? Well, here we have 2. We're multiplying the whole function by 2, and also the coefficient on the x term is 1/2. And if you've seen some of the videos I've made, you'll know that this term affects the amplitude, and this term affects the period, or the inverse of the period, which is the frequency. Either way, it depends whether you talk about one or the inverse of the other one. So let's start with the amplitude. This 2 tells us that the amplitude of this function is going to be 2. Because if it was just a 1 there, the amplitude would be 1. So it's going to be 2 times that. So let's draw a little dotted line up here at y equals, it's supposed to be y equals 2. And then another dotted line at y equals -2. Y equals -2. And now we have to figure out, so we know this is the amplitude. We know that the function is going to somehow oscillate between these 2 points, but we have to figure out how fast is it going to oscillate between the 2 points, or what's its period. And I'll give you a little formula here that the graph, or the function, is equal to the amplitude times, let's say, sine, but it would also work with cosine. The amplitude of the function times sine of 2 pi divided by the period of the function times x. Now it might not, this right here is a p. So it might not be completely obvious where this comes from, but what I want you to do is, maybe after this video or maybe in future videos, we'll experiment when we see what happens when we change this coefficient of the x term, and I think it'll start to make sense to you why this equation holds. But let's just take this as kind of an act of faith right now, that 2 pi divided by the period is the coefficient on x. So if we say that 2 pi divided by the period, 2 pi divided by the period is equal to the coefficient, which is 1/2. I know this is extremely messy, and this is separate from this. So 2 pi divided by the period is equal to 1/2. Or we could say 1/2 the period is equal to 2 pi. Or the period is equal to 4 pi. So we know the amplitude is equal to 2, and the period is equal to 4 pi. And once again, how did we figure out that the period is equal to 4 pi? We use this formula. 2 pi divided by the period is the coefficient on the x term. So we set 2 pi divided by the period equal to 1/2, and then we solve that the period is 4 pi. So where do we start? Well, what is f of 0? What is f of 0 here? Well, when x is equal to 0, this whole term is 0. So what's sine of 0? Sine of 0 is 0, if you remember, or I guess you could use a calculator, but that's something you should remember, or you could relook at the unit circle to remind yourself. Sine of 0 is 0, and then 0 times 2 is 0. So f of 0 is 0. Right? We'll do it right there. And we know that it has a period of 4 pi. That means that the function is going to repeat after 4 pi. So if we go out, it should repeat back out here at 4 pi. And now we can just kind of draw the function. And this will take a little bit of practice, but actually I'm going to draw it and then we can explore it a little bit more as well. So the function is going to look like this. Oh boy, this is more difficult than I thought. And then it'll keep going in this direction as well. And notice the period here, you could draw it from, you could do it from here to here. This distance is 4 pi. That's how long it takes for the function to repeat or to go through one cycle. Or you could also, if you want, you could measure this distance to this distance. This would also be 4 pi. And that's the period of the function. And then, of course, the amplitude of the function, which is this right here, is 2. Here's the amplitude, and then the period of 4 pi we figured out from this equation. Another way we could have thought about it, let's say that, let me erase some of the stuff. Let's say I didn't have this stuff right here. Let's say I didn't know what the function was. And let me get rid of all of this stuff, right? And all I saw was this graph, and I asked you to go the other way. Using this graph, try to figure out what the function is. Then you would just see, oh, well, how long does it take for the function to repeat? Well, it takes 4 pi radians for the function to repeat. So you'd be able to just visually realize that the period of this function is 4 pi. And then you would say, well, what's the amplitude? The amplitude is easy. You would just see how high it goes up or down, and it goes up 2, right? When you do the amplitude, you don't do the whole swing. You just do how much it swings in the positive or negative direction. So the amplitude is 2. So I'm using the wrong color. The period is 4 pi. Amplitude is 2. And then your question would be, well, this is a periodic function. Is it a sine or is it a cosine function? Well, cosine function, assuming we're not doing any shifting, and in a future module I will shift along the x-axis, but assuming we're not doing any shifting, cosine of 0 is 1, right? And sine of 0 is 0. And what's this function at 0? Well, it's 0, right? So this is going to be a sine function. So we would use this formula here. F of x is equal to the amplitude times the sine of 2 pi divided by the period times x. So we would know that the function is f of x is equal to the amplitude times sine of 2 pi over the period, 4 pi, x. And of course, these cancel out, and this cancels out, and this becomes 2 sine of 1/2 x. I know this is a little difficult to read. My apologies. And I'll ask you a question. What would this function look like? F of x equals 2 cosine of 1/2 x. Well, it's going to look the same, but we're going to start at a different point. Cosine, what's cosine of 0? When x is equal to 0, this whole term is equal to 0. Cosine of 0, we learned before, is 1. So f of 0 is equal to 2. Let me write that. F of 0 is equal to 2. So f of 0, let me do this in a different color. Let me draw the cosine function in a different color. We would start here. F of 0 is equal to 2, but everything else is the same. The amplitude is the same, and the period is the same. So now it's going to look like this. I hope I don't mess this up. This is difficult. So now the function is going to look like this. And you're going to go down here, and you're going to rise up again here. And on this side, you're going to do the same thing and keep going. So notice, the cosine and the sine functions look awfully similar. And the way to differentiate them is what they do, well, what they do in general, but the easiest way is what happens when you input a 0 into the function. What happens at the y-axis, or when x is equal to 0, or when the angle that you input into it is equal to 0. Unless we're doing shifting, and don't worry about shifting for now, I'll do that in the future modules, sine of 0 is 0, while cosine of 0 would be 1, and since we're multiplying it times this factor right here, times this number right here, the 1 becomes a 2. And so this is the graph of cosine of x. This is the graph of sine of x. And this is a little bit of a preview for shifting. Notice that the pink graph, or cosine of x, is very similar to the green graph, and it's just shifted. It's just shifted this way by, well, in this case, it's shifted by pi, right? And this actually has something to do with the period or the coefficient. In general, cosine of x is actually sine of x shifted to the left by pi over 2. But I don't want to confuse you too much. That's all the time I have for this video. I will now do another video with a couple of more examples like this.